Here this question is asking, write a code fragment which adds the 16-bit contents of ABCC. And here if you look at this one, this is given respectively. So here what we have to do is we have to this one first, which adds the 16-bit contents of ABCC to this one, and here we have least significant bit provided and also most significant bit provided. The first one is least significant bit. Here what they are saying is we have to load this one first and then add this one with this, and then we have to store it over here. Okay, that is what it's saying. And then for the most significant bit, we have to load this one first. I use a different color so we can distinguish. So this is the most significant bit. We have to add that one with this and then store it over here. That's what we have to do. That's the A part of this question. So let's go ahead and do that. Go to mention part here. This is A part of the question, and there's a B part as well. But let's deal with the A part of the question. So first, let's deal with the least significant bits. That's first address is provided right here. So what we do, we just load that one first. LDAA, load into accumulator A, and then the value we are loading, this is what we are loading, ABCC. So I put that one right here, and then we add that one with this one, ABCE. So for that one, add with accumulator A, ADDA, and that one is ABCE, and then what we do is we store it over here, ABCA. So to store, we put the statement STAA, store in accumulator A, and here we store it in this locus, that's ABCA. Okay, so that is what this one doing, and also we are not done yet. This is just the least significant bit. Now if you look at the most significant bit, that is ABCD, we had load that one first. So again, do the same process, LDAA, and then in this time we are loading the ABCD. Then we are adding ABCD with this ABCF. So we put the add with the accumulator A, and then ABCF, and then store it in the ABCB. So STAA ABCB. So this is what has to happen, and this is for the part A. Now let's look at the part B. In the part B, they are asking, write a similar code fragment which adds the 4-digit binary coded decimal contents of BCD, most significant bit, least significant bit is provided, and here also this one done respectively. So if you look at the most significant bit, that's provided the first value, that has to be added with this and store it over here. And the least significant bit, if you look at this BCDF, that has to be added with this and then store. Let me use a different color. This one, most significant bit, that has to be added with this. I'm looking at least significant bit. Most significant bit is the first one we looked at. Okay, let's look at the least significant bit. This is least significant bit, that has to be added with this and store it over here. Okay, so this is what has to happen. So let's deal with them. But here it's going to be a little bit different, that when you are doing with the hexadecimal, you can just directly do it, but when you are doing with the binary coded decimal, then you have to use a DAS instruction that is called decimal adjust accumulator A. That has to be happen after every addition process. So let's see how that one works. So first let's look at the least significant bit first, that is the second lines provided, that is BCDF, that has to be loaded first. We are loading the BCDF, and then we add this one with that, add a BCE one, and after the addition process, what has to happen is we have to put a DAA statement. What does it do is it's just gonna do the decimal adjust accumulated array. What does it do is it's put 6 on everything that is going above 9. Like for example, if you put F1 plus, that's over 9, and that's gonna do the correction by putting a 6 to it. And also it's gonna do everything that is, if the addition is above 9, it's gonna do the decimal adjust accumulated rate. So this is gonna correct it. That's why we put it right here, and then after that we are gonna store it. The storing location for the least significant bit is BCDD, STA, BCDD, and the same thing has to happen for the most significant bit. So we have to load it. First value is BCD, then we have to add it. The one we are gonna add here is the first one we are looking at, BCE0. And then here also, this is also a binary coded decimal. The whole thing is a binary coded decimal for the B part. So after every addition, we have to do the decimal adjust accumulated array. We put the DAA statement here, and then after that we store it wherever it want to store. So I'm looking in the most significant bit, that's the first one provided, so STAA, and then store it over here, BCDC. Okay, and that's how we do this kind of problems. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.